Hello geometry students. This is a video of example 4 for geometry topic 3 lesson 2. We're going to relate translations to reflections. How is a composition of reflections across parallel lines related to a translation? So we have the original triangle ABC. It gets reflected about the y-axis and ends up at A prime, B prime, C prime. And then that image gets reflected about the line, this one here, M, which is at right now at x equal 4, and it ends up at A double prime, B double prime, C double prime. That's how you can notice the progression. Start at the original points without any marks, and then here's the first image and then the second image, because it's got two. If there was a third image, it would have three. It'd be B triple prime and A triple prime. All right. They want you to notice a couple things. One, that after the first reflection, the orientation of the figure is reversed. So from here to here, notice it's been flipped and reversed, the orientation. Then after the second reflection, the orientation comes back to what it was in the pre-image. So notice triangle A double prime, B double prime, C double prime is in the same orientation as ABC. So that's what's going to happen when there's a reflection about two parallel lines. And if one of the parallel lines is an axis like this one is, it's the y-axis, there's something else you can notice. Right here is what they write, and I'll see if I can help you make sense of that. When the distance between the corresponding points on the y-axis and the line M is 4 units, from here to here, it's 4 units. Notice this translation. If you just went straight from ABC to the double prime, 1, 2, 3, 4, 5, 6, 7, 8. And when I move this line, let's say I move it to 3. So now it's 3 units away. Notice what happens here. 1, 2, 3, 4, 5, 6. When I move it to 2, 1, 2, 3, 4. So notice whatever the distance is here, the translation is doubled. So it's a translation of 4. Excuse me while I turn off my phone. It's ringing right now. Thank you. Let's see. So it's a translation in just the x direction because it was a reflection about vertical lines. And you can write that composition because that's what they know. How is a composition of reflections across parallel lines related to a translation? All that reflection, the double reflection there, is the same thing as a translation. 8 units in the x direction. You're typically not going to have this kind of a problem where there's double reflection about parallel lines, but we do have it in this example. Suppose n is the line with the equation y equals 1. Given triangle DEF with vertices at 0, 0, 0, 3, and 3, 0, what translation image is equivalent to reflection n in a composition with a reflection of the x-axis? Notice they use the x-axis this time, so we can still go with that it's just double. N was the equation y equals 1. So if I double 1, I get 2. Now this is the x-axis, so it's really a translation. Since it's going over the x-axis, those are horizontal lines. That changes the y value. So the x value stays the same, and the x value is doubled. Let's see what they wrote. Oh, maybe I should write the ending points. The ending points, D double prime is going to end up at 0, 2. Wow, that wasn't much of a change there. I'm just adding 2 to the y values. E double prime ends up at 0, 5. And F double prime ends up at 3, 2. They didn't write down where they ended up, but a double reflection across the line y equals 1 and the x-axis does end up being a gain of 2 in the y direction. Okay, I don't know if that was enough to explain this section, but that's the end of the example. So here are the problems that you can do. 13, 20, 25 through 28, 14, and 31. That's it for this video. Have a great day.